tuning in today. I hope you're all feeling motivated and ready to dive deeper into today's workshop. If you've been with us for the past sessions, welcome back. And if you're joining for the first time, we're thrilled to have you on board. I'm Vivash, and I'm excited to be your host for today. It's fantastic to have you all here with us today for SPM In Action 2.0. Whether you're tuning in from home, school, or anywhere else, we're excited to kick off this session and support you on your journey towards SPM 2024 success. Quick heads up, scan the QR code to check out our event booklet. It's got all the essential event schedule, guest speakers, sponsors, and more. Take a look and enjoy the event. Before we get started, we would like to encourage everyone to engage with us on Slido today. The link has been sent in the chat box. You can leave some questions you have for our speaker today throughout the session. So before we begin, just a few housekeeping items. Mute your microphones. Please keep your microphone muted unless you're speaking to avoid background noise. If you have any questions, simply raise your hand during the Q&A session and unmute when cued. Stay engaged. Use the chat to interact, share ideas, and connect with each other. This is a collaborative learning space. Feel free to ask questions or answer questions from speakers. Be respectful. Treat everyone in the workshop with kindness and courtesy. Respect the speaker's time and effort by listening attentively and refraining from interrupting when someone else is speaking. Now, let's get started and dive into the session, which is all about additional mathematics. It is my absolute pleasure to introduce today's speaker, Sir Matthew, an educator with over 15 years of experience teaching additional mathematics. Not only is Sir Matthew an experienced teacher, but he is also a passionate YouTuber committed to helping students succeed in mathematics and additional mathematics. Sir Matthew is the founder and mastermind behind the highly successful YouTube channel Y equals MX plus C, where he has built a community of over 130,000 subscribers. On the Y equals MX plus C channel, Sir Matthew has uploaded over 1,000 instructional videos dedicated to SPM preparation, covering everything from key formulas to complex problem-solving techniques. Whether you're looking for a quick revision or an in-depth explanation of challenging topics, Sir Matthew's videos are an invaluable resource for students. Sir Matthew holds a bachelor's degree in psychology, which adds a unique dimension to the teaching style. By combining his understanding of human behavior with his teaching expertise, Sir Matthew is able to connect with students in ways that not only make learning maths easier, but also more engaging. Today, Sir Matthew is here to share practical strategies that will help you approach your additional mathematics exam with confidence, ensuring that you're well prepared to tackle any challenges that come your way. So, let's give a warm welcome to Sir Matthew, our additional mathematics expert, and get ready for an informative and engaging session that will make your AdMaths preparation both effective and enjoyable. Sir Matthew, the floor is yours.
All right. Good morning, everyone. So, yeah, today we're going to learn some MF, and I will start by sharing my screen. Is it okay?
Yeah, it's okay.
Sharing. Oh, yeah, I think. Okay, can all of you see the screen? Yes, right?
Yeah, I can see.
Okay, good. Okay, today I will use the SBP 2024 paper 2 in this 3-hour section. So the reason why I choose this paper is because among all the state paper, this one consider average. Not like a loss, okay, but like Kelantan, or even Sabah also, some students say hard. Yeah, this paper is average, and yeah, it has some difficult question, but overall, I think it's suitable for most of the students. All right, so I will start with some formula because if you join, if you do the past year paper like many years ago, you realize they give more formula. So for this KSSM, they actually reduce the formulas to only 44. So I will add some formula which I think you need to know, yeah, before we really go into the questions. So because this is the formula is needed. Okay, so the first thing is about quadratic. So if you see carefully, you should know the first formula is a quadratic formula. Yeah. So But the quadratic, we have a lot of formula, but here they only give us one of the formula only, which is this one, the simple quadratic formula. So anyone knows any important quadratic formula here? Okay, one is very important, is called vertex form. Because I guess a lot of you heard about completing the square. Because we have a general form in quadratic, which is y equals to ax squared plus bx plus c. Then the process from the general form go into the vertex form is called completing the square. This is the vertex form. H squared plus k. Y equals to a x minus h squared plus k. So the process we call completing the square. Okay, so yes, vertex form is one of the very important formula, because why? This equation actually tell you the vertex. No matter your maximum or your minimum, you can straight away know the coordinate is called h and k. Okay, definitely maximum when a is less than 0, minimum when a is more than 0. Okay, this thing I should assume you already know. Okay, except the vertex form, what else quadratic formula is important here is the sum of root and product of root. Yeah, because they always ask you to form a new quadratic equation, yeah, in the sum of root and product of root. So you should know this another equation is called y equals to x squared minus sum of root x plus product of root. Yeah, this is when you have sum of root and product of root. If you want to form an equation, you will actually using this one. Okay, then the last thing is about b squared minus 4ac. Yeah, they will always tell you they will intersect two distinct and real root, or they does not intersect at all, or the straight line will be tangent to the curve. So everything is related to the discriminant b squared minus 4ac. So for b squared minus 4ac here, okay, we should have 3 options normally, but here I will tell you the 4th one. Okay, so b squared minus 4ac, I believe all of you definitely know this because it's just one more month for SPM. So we have equals to 0, we have less than 0, we have more than 0. Okay, so you should know equal to 0 means they only intersect one point, which is the keyword here is tangent. The curve will tangent to the straight line, or straight line tangent to the curve. Less than 0 mean keyword here is the does not intersect. And more than 0 definitely means intersect 2 points. But we have the 4th one, which is more and equals to 0. The keyword here is after real root. Okay, because what? Of course, this is a keyword, but this is not the proper definition. Because the proper definition for equals to 0 is what they call 2 equal and real root. Okay, here I want to explain like one by one. First thing is, just like I say, they intersect 1 point. But why I have a words of 2? I believe you definitely see some equation like this, right? Maybe x squared minus 6x plus 9 equals to 0. If you solve the quadratic equation like this, right, you will get something like x minus 3, x minus 3. So you will definitely get one answer. Actually, you get 2 equal x answer. This is the reason why they say 2 equal and real root. Root here means the answer of x. Or some reference book that will tell you it's an x intercept. Real here mean they are real number. So far, all the number you learn from primary to secondary to form 5 are all real number. Until you go to the SPM, you will learn something called complex number, which is the the I, you will see the I, yeah, imaginary number. But so far, except the imaginary number, all number you know right now is a real number. But why they want to mention about real number is because of the quadratic formula. Just now I showed the first one. And you realize b squared minus 4ac is over here, isn't it? And then in the real number world, when b squared minus 4ac is negative, then we need to solve something like, example, is negative 2. So therefore we will say, oh, no real root. Why? I say real is a real number, root is the answer of x, right? That means there's no real answer of x, because square root negative 2, calculator tell you is math error. But if you learn quadratic further, I believe your textbook definitely explain about the I. You should know this one will be math error if and only if we are using real number. What if I change my calculator to the complex number? Then now I type again square root negative 2. Do you see? I doesn't get math error. I get square root negative. I get square root 2i. That means if I doesn't care about this word real, actually can solve this square root negative 2. So then I cannot prove it does not intercept. So therefore, real is very important because it says about real number. Real number is whatever you do in the first calculation. So here tell me math error basically mean there's no answer for real number. And why I want to explain so much about this one, because if you see the third one, which is bigger than 0, this one bigger than 0, they say 2 distinct and real, right? 2 distinct and real root. And then you realize both of these also have the keyword real root, right? So therefore, I can combine both of the symbol, bigger and equal, to get my fourth one, mean have the real root. Why is important? Because sometimes if they want to come out more tricky, they doesn't tell you the curve and the straight line is intersect 1 point or 2 points. They just tell you this quadratic has real root. Then you cannot just say, oh, sir, has real root, is it mean equals to 0? Or is it mean bigger than 0? No, it's being combined of both. It's bigger and equals to 0. Okay, this is the fourth one. Normally it's not that common, but it will come out if they can come out with something like this. Okay. All right. So then, okay, this is a thing you need to know about quadratic. So we move on because so many formula here. All these are quite basic formula, but here we have one important indices formula I think students should know, which is let's say today I have the maybe a power of m multiply b power of m. What will we get? Any student know if a power of m multiply b power of m should get what? Or make it simple. 2 power of 9 multiply 3 power of 9. What do we get? Of course, you don't tell me you type in the calculator a very big number. When they have the same power, we can just multiply their number to get 6 power of 9. So therefore, this one, if we multiply this one, we actually get like AB power of m. Okay, this indices law normally will use for those K-bar type of question, but also very common when you do some square root question. Like today I have square root 5 multiplies maybe square root, I don't know, square root 3. Actually we are getting square root 50. Why? Because square root is actually 5 power of half, right? Multiply 3 power of half. Do you see they have the same power here? Then we can multiply the number. Become 5 multiply 3, power half. So this is a reason why it's a half. So the reason why we get square root power 50. Square root 50. And then you might say, sir, you sure or not? Okay, we do some simple examples. So in the exam, you might get a bit confused. So example, we do 2 power of 2 lah. We make the number very small so that you can easily understand 3 power of 2. This is 4 multiply 9, right? Then you get 36. So if I do the shortcut, 2 times 3 is 6 power of 2. Am I getting back 36? Yes, right. So therefore, it makes sense. Okay? Same power, we can just multiply their number. Okay, this is something I would say is a bit important, because if you do not know some difficult indices question, you might not able to solve. Okay, so here there's nothing special. But for law, there's something I wish all the students know. One of the past year question that come out something like this. When this is x1, and then ask student to state the value for this one. Anyone know the answer? It's a very simple question, 1 mark question. Any student want to try? Can student type in the message? Oh, okay, yeah. The answer is 0. Because 1 is a magical number. Because you should know, any number power of 0, you are getting 1. So therefore, 1, here I can say this one is x power of 0. So if this one is x power of 0, 0 I can move to the front. Become 0. Log x base and this one is the same, we get 1, right? So therefore, we are getting 0. So they don't need to tell you what is the base. Whenever you see the 1, it's 0. So if, example, I can write along 9 for the base, I put a 1 here, do you see? Entire thing actually getting a 0 here. Okay, this is some information I wish you know. And then next thing is about ln. Okay, so if ln x equals to 2, you should know ln actually is a shortcut for the log base e. So therefore, log base ex is equals to 2, x equals to e power of 2. And at the same time, because ln is the log base e, so therefore, if you see ln e, you should know it's equals to 1. The good news is, this one you can type in the calculator. Calculator definitely will tell you, so you don't really need to memorize so much. So it's just 1. Okay, this is about ln. It's not that common, but yeah, it can come out about ln. So let's say this is ln e5. This one is just equals to 5. And then got something example. Today I have a log base a, and then this is k. Yeah, this one come out few times in the kertas percubaan. Whenever this number same with the base here, we can simplify it, say this one is a k. I give you some example. So let's say today I have 2 log 2 5. So this one equals to 5. So of course I can show you power of log 2 5. See, you are getting 5. Okay, these are the shortcut lah. Definitely you say, sir, but how do I prove it or work on it? Then you need to let this thing equals to x and you try to solve it. Okay, but these are some shortcut I wish the student know. So when you do the question, you can do faster. And chain base, actually we have another chain base formula. Today, let's say this is log base a and b. We can do 1 over to sort the a and b, become log ba. Okay, this is just another chain-based formula. Sometimes we use if faster. Okay, so yep, we done about log and indices, and for the TN things, I don't think anything important you will miss here. Of course, you should know these two is for the AP, arithmetic progression. This three is for the GP lah, geometry progression. But for AP, there's a shortcut if you know the last term lah. So it's n over 2a plus l. Yeah, if you have the last term and you do not have the common difference, yeah. And then at the same time you need to know the n. Or I give you some examples. So let's say today n have 50. The first number is 1. And then it doesn't tell you what is the next number. And then I say, oh, the last number is 99. And then total they have 50 terms. And then I want to add all of them. Then I can do 50 over 2, 1 plus 99. Then I can get the final answer. But seldom we have chance to use this. I would say it's because I do so many of the questions. Yeah. But then yeah, L is the last term, just in case you do not know. Yeah. And then this one is a GP, nothing special. Yeah, in the SPM, they love to ask about the range of R when sum to infinity exists. So this one actually is a shortcut for R is in between -1 to 1. Because I think I saw one of the exam paper coming like that, come out something like this. They say, oh, sum to infinity exists. So then they write this one A and B. And 1 mark only, they ask the student state what is the value of A and B. So you should know you can only find sum to infinity when the common ratio, which is R, is in between -1 to 1. Okay, this is something I think is important. And then sometimes they will use a more professional words. They use the word convergent. Basically, what the convergent trying to means is, this is your Sn, this is your n term. When your n term is increasing, eventually the number will go to the constant. It will go here. They will become a flat now. So then this one is called convergence. Then we can calculate sum to infinity. Or else, the opposite of convergence is divergent. This one, sum to infinity is equal to infinity. I mean, sum to infinity is equal to infinity. It cannot become. Or they can go down. It will go to the negative infinity. So it cannot be solved. So therefore, this, in order to make it have to make the progression become a convergent, then the R value must be always negative, between -1 to 1. Okay? Yeah, this is just some extra knowledge. I hope it might be helpful to you. Differentiation, nothing much. This one you should know is a product rule, is a quotient rule. This is a rate of change rule. This one is the change rule. Yeah, definitely they doesn't tell you all the formula because they only stop here. So then definitely you have to add a small change by yourself. This one is chain rule, but we use the chain rule in the rate of change, so we will modify the chain rule a bit later. So small change is just change of y over change of x equals to dy dx. Okay, and then we always sub the original x value into dy dx lah. Okay, and yeah, change rule. But then if you want to do a rate of change, we are talking about the time. So normally the more proper equation will be dy dt will equals to dy dx multiplied dx dt. Okay, this is what we always use for the rate of change, a small change. And then we have something we call approximation. Approximation basically is we want to get a new value of y. We'll use the old value of y plus the change of y. Okay, so yeah, this is an approximation. If you see some question like this, maybe we can try to use it. But here I just let you know. Okay, then we go to the integration. for this one is for the area. Yeah, you have dx and you have dy. You should know dx basically means go to the x-axis and go to the y-axis. Okay, so, but here I want to tell you something about the value. Let's say we go to the dx first, which is the first one. Okay, y dx. You have a random area like this. This area, right now we are talking about dx, will be positive. The value below the x-axis, this is x-axis, okay, will be negative. Okay, in SPM, there's something they call, it's a bit confused. If today we are finding the area, you need to modulus the negative one whenever possible. But if the question doesn't mention about values, they just want to find from A to B. Let's say I want to integrate A to B for this equation I call fx, for this fx dx. Then my answer must have the negative. Because if the question just tell you they want to integrate this one, they doesn't mention this one is the area we don't put a modulus for it. We don't always assume, oh sir, is it always we need to a modulus become positive? No. It will just remain negative. Unless today they mention about area, then we will just make it become positive. But this one I believe a lot of students know because it's very common. But what happened to dy? The second one. If today we have x dy, then we are talking about y-axis. So that's mean, yeah, let's say I have a random area also. This area here, even though it's below x-axis, it's positive. Because right now we focus on y-axis, left and right. So before the y-axis, this area will be negative. Okay, this is what happened for dy. And then for volume, just something I want to mention. Until today, still a lot of argument. Even between the teacher, we still have a bit argument is on the rotate. 180 degree. I believe you do enough question about how to find the volume using integration, you definitely will see the question they say rotate 180 degree. And then now what's the argument is, should we divide 2 if they rotate 180? Because we will form a volume if we rotate 360, right? But what happens if you only rotate half of it, 180? Should we divide 2? Okay, short answer is no. But why? You need to know why, right? This is the reason why you come to learn MF. Okay, because the reason why I think some books, even some reference book, they make students very confusing. Is because maybe they saw some rotate 180 and never divide 2, then they apply to all the cases. No, rotate 180 and no need to divide 2, only apply on some specific cases. Example, I use some cases rotate on the y-axis one, okay? Or want to rotate on x-axis also can. Let's say rotate on x-axis. Let's say today I have some area like this. Okay, let's say this one top is the area A, bottom is the area B. And area A must be symmetry to the area B. They are totally same size. Okay, area A and area B, they are the same. Then they rotate on the x-axis. They just need to rotate 180 degrees to form the full volume. You might say, sir, what is the difference? I show you another one. This one I only have area A. This one is one to form a full volume, he need to rotate like 360 degrees. Do you see the difference? Because one, you can imagine for the first part, the A actually they rotate half of it 180. Then B they rotate another half of it. So because they are A, B, they are entire equation, right? So therefore, each rotate 180 and 180, they actually get full volume. But this one, they only have part A, they without the part B. Then they want to get a full volume, they have to rotate 360 degrees to get a full volume. So therefore, you will only see rotate 180 when you have the cases like this. They have the entire plane, and yeah, so like this part in charge rotate 180, this part rotate another 180. So you actually getting the full volume. So you don't need to divide 2, even though you see here rotate 180 degrees. Okay, so this is something I would say, yeah, it's important. Then index number, nothing special. NPR, NCR, nothing special. Yeah, just okay, this one binomial, normal distribution, and then circular measure. Yeah, for NPR, NCR, just arrangement for circle lah. This one is quite famous, right? We have a arrangement for circle. Yeah, recently they always come out on n-1 factorial. Yeah. So yeah, there's nothing I want to mention over here. And then this one is circular measures. Yeah, circular measure, sometimes I will use some shortcut. I lazy to draw, I will use a formula for chord. Just in case some students do not know what is a chord. Let's say this is a sector. The line cut the sector in the triangle is called chord. Yeah, normally I will use a shortcut formula. 2r sine theta over 2. So it's faster way to help me to find a chord. And then let's say this part we call segment. Yeah, sometimes if I want to find an area or segment very fast, I will just use this shortcut, half r squared theta minus sine theta. Yeah, but all this formula you can do manually without like memorize this formula, because this one actually is a sector minus triangle only. And this one actually is you get from the Socatua if you split this triangle into the half, and then you got a theta over 2. Then you do a Socatua to find. Yeah, that means you can still do manually without knowing the formula. But yeah, I'm a bit lazy, so normally I will do all the shortcut. Then over here is the identity formula. Yeah, these 3 formula normally we use for proving. But then yeah, we can use the bottom for proving because right now the proving actually become more and more complicated. Nothing much I want to say. If you really ask me, I will ask you to know how to get the half angle, like sine A over 2, cos A over 2, and tangent A over 2. Because yeah, these are the K-Bar favorite lah. They will always ask you to get the half angle, because we have the double angle. But then how to get the half angle? The short story is all the half angle come from the cos 2a. So it come from this formula. So yeah, since I think we have plenty of time in it, so yeah, I will take my time. So I know some of you are waiting for the paper discussion, but yeah, this knowledge is equally important. So let's say you want to get a sine half angle formula. So you look for the cos 2a only have sine 1, which is the last one, isn't it? So let's say cos 2a is equals to 1 minus 2 sine square. So I let my a become a x over 2. Yeah, then I will get x over 2 here lah. So if I insert here, I will get cos 2 x over 2 equals to minus 2 sine square x over 2. So this one cancel, we get a cos x, isn't it? So I will rearrange it. So I say, oh, 2 sine square x over 2 equals to 1 minus cos x. Then 2 I can move to the other side. I divide it by 2. The square I can move to the other side, become a square root. Let me done. Do you see? I come out a sine half angle. So you will use the same method. If today I want to find the cos half angle, I will use the second one. I will use this one. Cos 2x equals to 2 cos square x minus 1. So I do the same thing. I make this one become a x over 2. Then, yeah, you solve until the end. You will get cos x over 2 equals to square root 1 plus cos x over 2. Sadly, for tangent half angle, there's no shortcut. So normally, how we get tangent half angle, we combine both of these. Because tangent x over 2 is equals to sine x over 2 over cos x over 2. Then you can just insert your formula, 1 minus cos x over 2 over square root 1 plus cos x over 2. Yeah, then you simplify this one. You will get 1 minus cos x over 1 plus cos x. Then you can multiply 1 minus cos x or 1 plus cos x to further simplify it, but I will just stop here. So, I will just stop here for this formula. So this one will be tangent half angle. Yeah, I would say among the 3 half angle, tangent half angle is more complicated one. Because there's no shortcut you can straight away get from a double angle. Some student might say, sir, why can't I use the tangent 2a to get the tangent x over 2? You can try. It's very complicated to use a tangent double angle to get a tangent half angle. So I'd rather use a sine half angle divided by cos half angle. It's easier. Okay? Then nothing much here. And then here, this 3 is a solution of triangle. Solution of triangle. Yeah, nothing much I want to say about solution of triangle. Yeah, ambitious case you need to know lah. And then these 2 is for the coordinate geometry. Coordinate geometry a lot more formula, but then so got few. I just mentioned few important one lah. First is the distance formula. Distance formula is one of the most important formula in coordinate geometry because what? We always use it to form the locus equation. So if one formula you must memorize in this topic is a distance formula. And distance formula actually came from the Pythagoras, right? A squared plus b squared. Just because a is a change of x. So therefore, x2 minus x1 squared. B is a change of y, so y2 minus y1 squared. So do you see the pattern look like this? A squared plus b squared. This is my A, this is my B. Then actually it's a Pythagoras. This is how you should memorize the distance formula. And then the second important is the perpendicular, which is the 90 degree lah. First gradient multiply second gradient equals to -1. You will also use this formula in the difference 10 divided by 2, which is 5. Okay, I think no, I need to get the number bigger because if not, maybe this is 4, 3. Yeah, because because just now I think the triangle is not possible. I will get 0. 4, 3. Okay, then you plus, then this is 12 divided by 2, and s is 6. Okay, now you can do. So this is 6, and 6 minus 5, 6 minus 4, 6 minus 3. Yeah, just, oops, sorry. Just that simple. Okay. So yeah, this is how we use the Heron formula. Yeah, which I think is important. I see a lot of students raising hand. Is there any way I respond to them or just student misclick it? Okay. I think student can just type, right? So yeah, you raise hand, maybe you just type your question so it's easier for me. Okay, this is everything about coordinate geometry. And then lastly, this one is the area. Then lastly, we have the vector, unit vector. Yeah, nothing much I want to add here. Okay, so far about formula, is there any formula you may want to ask me? If no, then I will move on to the paper discussion finally. All right, Z value table. Yeah, let me mention a little bit about Z value table. Yeah, actually nowadays we can use this calculator to solve almost everything in this table. But then, yeah, if you're still using the old model, which is 570 MS, this is the black color one. Yeah, then you might need to use this table. This calculator also can do something like this, but it's in a much complicated way. Okay, so if you want to use this table, you need to fulfill two conditions. First thing, this Z must be bigger than your A, or is bigger equal. Okay, symbol must be bigger or bigger equal. Condition number one. Must be bigger. Condition number two, A must be positive. A must be positive value. That means if A is negative value, you cannot straight away use this table. I give you some example. Let's say today I have Z bigger than negative 1.2. Then you can't straight away use this table. Because why? I say A must be positive. And then some student might ask, sir, why can't we just use it? If you know about bell-shaped diagram, you should know 0 is here, negative 1.2 maybe roughly here. Bigger is this area. Probability is the area in the bell-shaped diagram. And half of the area here, because the total area is 1, right? So if I divide into the half, here is 0.5, here is 0.5. So therefore, half here is 0.5. So this area, I can conclude, is more than 0.5. Why is it important? You check your table. What is the maximum probability you can get? It's 0.5. There's no way you find more than 0.5 from the table. So therefore, if you really want to solve the cases like this, you need to use 1 minus, isn't it? So therefore, we will use 1 minus the pink color part, right? 1 minus probability, check less than negative 1.2. And less and negative happen together, we can change to more than 1.2 because there are symmetry here, isn't it? Both areas are symmetry. Then now, bigger, now positive, fulfill these two conditions, yes. Then I can find a 1.2 from the table, which is this one, 0.1151. Yeah, then 1 minus 0.1151, then we can get the area we want. Then which is 0.8849. Like I say, calculator can get pretty much quite very similar. You go to normal CD. Let's say I want to do more than negative 1.5. Calculator can type negative definitely. This one I will go 10 power 99, which is infinity. So do you see? I can straight away get a final answer, 0.8849. Yeah, definitely calculator can do, but then I don't know. Now I talk to some students say the teachers in the school say can use calculator. Some say no, teachers say must show, because if you can type in the calculator, that means you don't need these 3 steps. It's no need already. It give you this one, you can straight away get the answer, which I find a bit doesn't make sense, because normally this kind of question that will give you 2 to 3 marks, definitely other mark for the working, right? Cannot be you type the calculator, you straight away get the final answer. Maximum they give you 1 mark for final answer. Then where is another 1 and 2 mark go? So I think you still need the working. Okay? Yeah. Okay, now we go to the paper. Okay, so let me drink my tea for a while before we go into it. So when using the calculator to calculate the answer for normal distribution, what are the recommended decimal we should take? Good question. So you see here, if you want to find from the table, right, what is the maximum decimal you can get? Here is 1 decimal. This one give me two decimal. This one give me third decimal. So therefore, maximum you write for Z value, here A, maximum is 3 decimal place. Yeah, because here you can only, like example 0.249. Fourth decimal it doesn't show in the table one. And then your result must be 4 decimal. Depend like this one have more decimal, right? But then most of the result here, they stop at 4 decimal. You see? Result is 4 decimal. You seldom have chance to get all this value. So far I do so many normal distribution question. You seldom got chance to use the very small value. So therefore your Z value is 3 decimal, but your result you put 4 decimal place. If you want to, seems like you use the table. Because if you come out the 5th decimal, examiner definitely know you are not from the table. But I want to warn you also, because calculator sometimes is way too accurate until the last decimal will be slightly different, 1 or 2 units different for the last decimal, which is in the 4th decimal. So you must prepare for it. So I hope SPM marking scheme, they can give a little bit range. If not, if you calculator, you will get too accurate until your final result will be slightly different with the marking scheme. Okay. But if I'm a teacher, I will mark correct because I mean, as a teacher, we want to get the answer as accurate as possible. We shouldn't mark the accurate answer as wrong unless the paper mentioned like how many decimal, how you round off, pi must use 3.142, yeah. Or in the MF paper, the first page, does the paper say must use the Z table? Okay, they say this Z table disediakan did this one. But then here they doesn't mention must use, right? If they mention must use, that means, yeah, if your value different with the Z value table, then they can mark you wrong. Okay, I hope I answer your question for Yongming. Okay, now we finally can go into here. So a straight line with the gradient 1. And then we have the y in the y and cut the y-axis. Okay, this is very good news. You cut the y-axis, actually tell me C, right? C is 7, M is 1. So I can form the equation in just 1 second. Y equals to x plus 7. Done. We've done the straight line. And then this straight line touch the curve, which is x squared plus y minus 3 squared equals 8. Whenever you see the word touch, it doesn't give for fun. Touch actually, you can think it's same meaning in tangent. When the question use the word touch, normally they just intersect 1 point. So this is a reason why they use touch. They will just intersect at 1 point. Okay? Because if not, if they intersect 2 points, then normally they won't use the word touch. So intersect 1 point, tell me what? Tell me later, my x answer, I say tangent, these 2x answer must be the same x answer. This is the reason why they use the word touch. Unless they simply write, because sometimes final x answer makes sense based on the question. Okay, so yeah, then I will just substitute, sub 1 into 2, okay? So x squared plus x plus 7 minus 3 squared equals to 8. So this one is x plus 4 squared minus 8 equals to 0. Then I will expand this one as usual. This is x squared plus 8x plus 16 minus 8 equals to 0. Then I will solve this one. 2x squared plus 8x plus 8 equals to 0. Then divided by 2. It's a plus. Sorry about that. Yeah. So we have x plus 2x plus 2, isn't it? Or you can call x plus 2 squared. So your answer is -2. Then I sub back to my first equation. My y is -2 plus 7, y is 5. Then my coordinate k done, -2, 5. Do you see? I have two same x answer. X equals to -2, x equals to -2. But I will only write one of it, which is enough. Okay? Yeah, and here I think there shouldn't put an S for coordinates, because this one, if I read it, I will just assume, should I get more than one k value here? Because coordinates have the S, right? Yeah. So this one is a very basic diagram here, so nothing important information there. Okay, a point P moves such that its distance is always 4.5 units. Okay, so when you see something like a point can move one, this one hints you about locus. Oh yeah, they already tell you locus of P. So whenever you see locus, just now I say, most of the locus use distance formula. Some locus can use the perpendicular formula, yes. But most of the locus we use the distance formula. So distance, we need to have two coordinates. First, P is a moving point, so you must make P be x and y. This is how, because why we need to move let P be x and y? Because since it's a moving point, it cannot be a specific coordinate 1, 2 or 7, 8. It cannot be a coordinate, because once you give it a specific number, then it cannot move already, meaning it must be at that position. But if put x and y, means it's a variable, it can keep on changing. So this is a reason why they say, yeah, it's a moving point, so we must put it x, y. And then point A, I believe is given 2, 5. We have two coordinates, we can find distance. And then the question tell you what is the distance, 4.5. Then I will just say PA equals to 4.5. That's all. Then I just apply my distance formula. So distance formula is x minus x squared, y minus y squared equals to 4.5. Then we just solve this one as usual. So square both sides. Then I go to the 4.5 square. So I will get something like 81 over 4. Then no more square root, expand this one, 4x plus 4. Y squared minus 10y plus 25. Then this is x squared plus y squared minus 4x plus 10y plus 29 equals to 81 over 4. Depend you want decimal or not lah. If you go, then you just 29 minus 81 over 4. But if you don't like about decimal, then you multiply 4 for entire equation. I think the marking scheme, they just multiply 4 for entire equation. So 4x squared plus 4y squared minus 16. This is x, this is not y, sorry. Carry mistake. So 16x. Then plus 40y. Plus 29 multiplied 4. 116. And then minus 81. Equals to 0. I straight away my minus lah, okay? So this one will be, yeah, this one will be equation of locus. But like I say, I think it's fine to straight away use 29 minus 81 over 4. Yeah. To leave the plus here, then you just make it, here equals to 0, here is 8.75. Yeah, I think leave like, it's minus 10y, yeah, thank you so much. It's not plus 10y, it's minus 10y. Okay, I'm not sure what happened to my pen. Oh, my pen is not working suddenly. Okay, let me just restart my OneNote. I think, is it because of OneNote is working fine, just this pen. Okay, just give me a moment, some technical issue here. Okay, I think it's Okay, it's okay back already. Yeah, just some technical issue. I'm not sure why. Yeah, this one is minus 10y. So yeah, then this is minus 40y. Yeah, thanks Qingling to let me know about this. Okay, then next one. Then they ask us to find the P and Q. So whenever you see an equation like this, my recommendation is change it into a fraction. Then we change it into a ratio. So how? So 2AD equals to 3DC. So we make AD over DC. So which is 3 over 2. So therefore, AD ratio DC is 3 ratio 2. Then once you know this one, then we have an equation, we have a line like this. So I'm going to draw out this line. Then we will use the segment formula. This is a C, negative 4P. And then we have a D here. We have a D here, Q negative 1. And then we have an A here, 2, 5. So then based on the ratio, AD is 3, DC is 2. Then we can easily use our segment formula, isn't it? Which is 2 multiply the further x coordinate plus 3 multiply the further x coordinate divided by total ratio equals to the middle x coordinate. So therefore 2 multiply 2 plus 3 multiply negative 4 divided by total ratio equals to the middle x coordinate. Then we'll do the same thing for y coordinate. 2 multiply further y coordinate plus 3 multiply further y coordinate divide by total ratio to get the middle y coordinate, negative 1. So by solving this one, you can easily get your P and Q. Okay? So this one is 4 minus 12 over 5. So it's negative 8 over 5 or negative 1.6. Okay, so then this one, 10 plus 3p equals to negative 5, 3p equals to negative 15, p equals to negative 5. Okay, it's not too difficult. You just need to know how to use the formula. You consider quite easy, I would say. Is it okay? Anything you want to ask me about that? If there's no issue, then we'll move on to the next one. Find the equation of a line passing through B and perpendiculars to AB. Like I say, perpendicular, see this keyword, M1, M2 equals to negative 1 must straight away come out from the brain. And then equation of a straight line, you can do y equals mx plus c. Remember, whenever you want to find the straight line equation, you need to have two information. It's a must. First, you need to know the gradient. Second, you need to have a coordinate on the line. That's mean what? Let's say today I have point A and point B. I want to find this equation. I can never use the coordinate B to find that equation because why? B doesn't passing through that straight line. So therefore, you must use the coordinate on the line. Okay, this is like M for gradient, AB, I write like small like that. So y minus y over x minus x. So it's negative 3 over 2, isn't it? Then I have a perpendicular and passing through B. So therefore, I have a line, passing through B like that. So therefore, I want to find M2 . So negative 3 over 2 multiply M2 equals to negative 1. So M2 is 2 over 3. I have a gradient. Since it's passing through B, then I will use the coordinate B. Do you see? I fulfill the condition which I have a coordinate and I have a gradient. Yeah. And at the same time, this is not just a sim because it's a y-intercept. Oh, that is very easy. Y equals to mx plus c. Do you see that? 8 is a c because it's on the y-axis. Yeah, then this is how easy I get another 2 marks. Okay, just in case some students do not know gradient formula, y2 minus y1 over x2 minus x1. Yeah, just in case you do not know what is going on here. So normally I would just take a two coordinate y minus y divided by x minus x. Okay. Okay. Then we go to this question, a little bit hard. I won't say it's very hard, but then yeah, you need to think a bit lah. Okay, first thing is whenever you do the circular measure, you need to ensure the angle is radian. Is in the angle unit lah. Is radian. So because this one they give you 31 degrees, so whenever you want to apply s equals to r theta or half r squared theta, these theta are designed in the radian unit. So therefore, whenever you're trying to sub the 61 degrees straight away in your theta, the entire formula is wrong already, because this equation designed for radian. So you must be extremely careful. And some students are a bit confused, sir. Then I insert this formula. Should I change my calculator to radian? Then only I do it? No need. You need to change your calculator whenever there's a trigonometry, whenever there's a sine, cos, and tangent. But in these cases, yeah, you don't see any sine, cos, tangent at the equation, isn't it? So you don't need to change your calculator. Okay. Okay. So let's see. So diagram 2 show a val bulan, so which is a combination of two sectors of a circle. So OABC and then OPQ is a center O. So here they tell us this small sector has a radius of 10. Okay, we have 61 degrees. Okay, and then E, which is the center of E. Where's the center of E? Okay, radius 8. So this one have the radius of 8 here. It's inscribed in the sector OABC. So the radius, straight line OA and OC are tangent to the circle at the point M and N. Okay, so a lot of information you need to have here. First thing is, these two are the tangent line. What the good news about tangent is, tangent always will be perpendicular to the center. So here is 90 degrees, just in case you might need or might not need to use it, but you need to know lah. Tangent line to the center is always 90 degrees. This is the first thing. Okay, so, and then second thing, pay attention to this one. I always forget to change pi into 3.142. I just type pi in the calculator. Then it leads to, I get a too accurate answer. So it's different with the marking scheme. So when do that time, must be careful. Okay, then they want the parameter of the whole diagram. Okay, for this parameter of whole diagram here, 5 mark, and then area of the region. The only challenging part is, I have a radius for circle. I have the radius for this small sector, but I don't have the radius for this big sector. I do not know what is R. I need to find the R. So therefore, the radius for this big sector, I'm going to call it capital R, okay? So that you understand what's in the capital R here. But it's not too hard to find, because there's a circle inscribed into it. So, because I know this one is a right angle triangle. Here is 90 degrees, right? So, I just need to find the so-called hypotenuse of it. Then, from E to B is a radius. So this one is 8 already, I already know. And this is 8 also. And then this angle, because these two triangles are the same triangle, or we call congruent triangle. So therefore, the angle confirm divided by 2. So it's 30.5 degrees. Yeah. Then I can use the Socator to find my hypotenuse, which is OE. Then from there, I take my OE plus the EB, then I get the capital R. You got the idea? Now I'm going to draw out the triangle. Label it accordingly lah. So this is M, this is E, this is O. and then this is 90 degree. This is 30.5. And then I know the opposite is 8. I want to find the hypotenuse. Okay, so obviously it's a sine. So sine 30.5 degree equals to 8 divided by, or I write OE is easier than write a H. Okay, I want to find the length of OE. Sine 30.5. Okay, now you see my equation have the trigonometry already, have the sign there, right? So must ensure your calculator is in degree. So on the top of your calculator, you should see a D over there. That is a degree. So right now, I can type entire thing. Sine 30.5. Okay, so OE. Okay, this one I recommend you to take like 4 significant figures at least. So take 15.76. Okay. If you say, sir, if there's should I take a 3 or 4 decimal? I think if you want to be more accurate, you can take 1 more decimal. It's okay. Like add a 2 here. But normally 4 significant figures should be enough. But final answer must be 4 significant figures. Because until today, still a lot of argument like how many decimal want to take. Some teacher in the school, they say, oh, all must take a 4 decimal. I would say if you start with 0, then you take 4 decimal, yes. Because this is a 4 significant figure rule. If not, I think just take like this should be enough. Okay, my radius plus 8. So it should be 23.76 is my radius. Okay, now I can find the entire angle, entire parameter. But then the problem is I want to use S equal to R theta. My theta right now is 61 degree. So I need to change the 61 degree. How to change your radian? We'll multiply pi over 180. Okay, and the question already say pi must use 3.142. So we follow over 180. So I take this value as my angle, 1.065 radian. Okay, so right now the entire equation become extremely easy. Yeah, so you should know parameter of the sector is 2r plus r theta. Okay, so I have one big sector, two big sector, so yeah, I will go to use this parameter formula for 2 times. Okay, you got it. So I'm going to write here, maybe. So my 8. So the entire parameter, so it's 2r, right? So 2 of 33.76 plus r theta plus 33.76. Theta is 1.065. Then I still need to plus the small sector. Small sector is 10. So 2r plus r theta is 1.065. Okay, this is the big sector, this is a small sector at the bottom. So I plus all of them together, then use a calculator. You did get a mark. Okay, so total will be 13.5 centimeter. Or you want to do a 4.7 is fine. Okay, so this is how we get a parameter. It's not too hard. Then they want me to find an area of shaded region. And they give 4 marks. Okay, so in order to find area of shaded region, the bottom part is very easy. This part here is just half r squared theta, right? Or I can use a space here. This one is just half, my r is 10 square, theta I already find 1.065. So this one, yeah, is 50 lah. 50 multiplied 1.065. So this one is already solved, 53.25. Now the challenging is this part lah. Okay, so in order to do that, so the big sector is not too bad because I already, so the big sector is not too bad because I already have the capital R, which is 23.76. But I need a radian for 30.5, so to ensure I doesn't use a wrong value. So I think I redo again, multiply pi over 180 to get a more accurate answer. Actually, I can use just now answer divide by 2, but then I think I prefer redo. So it's 0.5324 radian. Okay, then now I can start to find that part of the area. So I take a big sector first, half r squared theta. My r is 23.76 square. Theta is 0.5324. And then I will minus the triangle. The triangles, I can do half AB sine C or I can do Pythagoras. Anything will do. Let's say I want to do because eventually I need to find that angle. Never mind. We find this angle first. This is 30.5, so I do 90 minus 30.5. I know that minus my answer. 120.5. Okay. So I now, because I already have my hypotenuse, right, which is OE, 15.79. 76, sorry. So then I can use half AB sine C for the triangle. Half A, A will be A, B is 15.76, sine C, 59.5. Okay, now I settle the triangle. Lastly, I need to settle the sector. Minus half r squared. Okay, theta, you realize 120.5 is in the degree, isn't it? So I will change the radian on the spot. So I will do 120.5 multiply pi over 180. Yeah, I just type everything into here, then I can get my final answer. Yeah, I would say final answer is not that important for me. I'm a bit lazy to type, but all the working is, oh no. Okay, you will get this answer, but this one is not the final answer. So therefore, area of shaded region. Just now, remember, we still need to plus a sector just now. This one 53.25. The small sector at the bottom. 53.25 plus this answer. Yeah, then I got my final answer. Yeah, 53.25, correct. Okay, this is how I get another formula. So far, is it okay? Anything else you want to ask me for the sector? So this kind of 9-mark question, I won't say it's very hard, but then you must do very careful. Especially this one include a lot of decimal. So remember about 4 significant figure and remember about pi. Because if today you do 120.5 multiply pi over 180, you type like this, your answer, okay? Because they are like, this one is a differentiate, this one is integrate, they are like redo and undo thing, right? So yeah, so you can always cancel each other whenever you see integrate and ddx at the same time. So this one means you already integrate, so you don't integrate 2 times. Okay, so if you understand this concept, right, then this 2-mark question is considered a 3-mark question to you already. So you go back to the question. Yeah, here they use the dt, but it's the same concept. So I'm going to write very easy. You take it outside, so no problem. So one minus t plus c. Done. If you see carefully for this kind of question, right, the whole process, you realize I never do a single integration, right? Do you see I integrate anything? No, right? I just simplified the integration symbol with the DDT. So therefore, this kind of question is test how much you understand about integration. I mean, it don't really want you to integrate, right? Because you doesn't do any integration. Okay. So then we go to the part B. Part B, they show you the fx and just show you the gx. Okay. Nothing special. Intersect at the point P. Okay. I give you equation for fx and gx. On the diagram above, show the region represented by gx minus fx from 0 to a. Okay. Okay. So I want to show you first. Let's say gx. I integrate the gx, right? I get the entire area from the gx, because then, do you see dx? To the x-axis. That means they will stop at x-axis. Because some students think the integration, they will go all the way beyond the x-axis. No, they will always stop at x-axis. I don't care the equation is above the x-axis or below the x-axis. They will always stop at x-axis only. So that means they'll stop here one. They won't go beyond the x-axis. So this shaded region is when you integrate gx from 0 to a. But you need to minus, you integrate fx, 0 to a. So if you integrate fx, I use a red color. This is fx, right? So you will get any area below the fx until you touch the x-axis. So you need to minus the red color part. Then, therefore, you only get the area at the middle. Yeah, you only get this area. So the question asks you to shade it up. So yeah, you're going to shade with the pencil, not highlighter like what I did here. Okay, for all the drawing, use a pencil. Okay, done. Then they ask us to find the coordinate of P. Remember this one, even though in the coordinate geometry is very often, whenever want to find a coordinate, right, I would say 8% you do simultaneous. You will need to find two equations which is passing through the point P, sub into each other, that's all. fx and gx both intersect at P, right? So sub this equation into this equation, that's all. So 3x squared equals to 2x squared plus 1. Then x squared equals to 1, x equals to plus minus 1. But in these cases, a is positive, right? Yeah, so I just take the positive one. Even though I know there's a plus minus. But if you write a plus minus, you need to remember to reject the minus version. So I just write 1. So how to find a y? Just 3x squared, right? Y equals to 3. Coordinate P done. 1, 3. Because you understand, you sub into each other, then this is how easy you get the coordinate. Okay, done. Okay, and at the same time, I know A is 1. Okay, then find the volume in terms of pi when the region powered by the gx, y-axis. Okay, this one is an extra line. It's not in the diagram. You need to draw yourself. Y equals 5. We got 360 about the y-axis. So first thing, gx. Okay, I need to know what is this point first. This one is called y-intercept, right? So for gx, we make x equals to 0. So you get 2 0 squared plus 1. So it's 1. So this value is 1. Then I can estimate maybe 5 is... Actually, 5 is a lot higher. But then here, because I want to show you, so I draw the 5 maybe somewhere here. Y equals 5. Even though the scale is totally wrong. Because this one is 1 unit, cannot be. This one is 4 unit. So this is the reason why the scale is wrong. But I just want to show you so it doesn't matter. So right now, I want to find an area powered by gx, x equals to 5, and also y-axis. So they are talking about this area. So this area they will rotate 360 degrees on the y-axis. But why not 180? If they are 180, then your area will look like this. Then you have the region like this. Then you will rotate 180 degree only. Do you see the difference? If like this, then you rotate 180 on the y-axis. But it's only one part of it, then you rotate 360. So over here, nothing special. But you know, if you rotate on the y-axis, your volume equation must be dy, isn't it? Pi a to b dy, so here will be x squared. So you need to solve one more thing is, you must have an equation in x squared, with x squared as a subject. So therefore, this is my gx, right? I will say y is equals to 2x squared plus 1. So my objective is to make the x squared as a subject. So this is y minus 1 over 2 equals x squared. Yeah, now I have x squared. Now I can sub into here. So, and then my limit is for 1 to 5, isn't it? 1 to 5. X squared is y minus 1 over 2 dy. I don't like over 2. So what I will do is, I will take the over 2 come out. So I can, my integration is a lot simple. I only integrate y minus 1. Okay, so I will integrate accordingly. So this one is y squared over 2 minus y and 5y. And then the rest of the work, you just do some substitution and solve it. So sub the 5 first, so I get 25 over 2 minus 5. Then we sub the 1 into here, I get 1 over 2 minus 1. Then you will just type the calculator. You should get about 4. You should get about 8. Then final answer is 4 pi. So if you're having the calculator like this, normally I will do one more step is, I want to ensure my integration is correct. So what I will do is, I will just use the function in the calculator. So I want to integrate from, I don't have the y, I will use x to represent it, okay, over 2, and then from 1 to 5. And then the answer is 4. So yeah, I'm very confident my answer will be 4. But why 4 pi? Because I didn't insert the pi just now. If you want to do exactly same, then you can just insert the pi here. Insert a pi here and multiply. The working, I think the final answer they did a little bit of mistake, but yeah, it's fine. We are human. Yeah, we make mistake. But don't make too much mistake in the real SPM exam. Yes, it's about 10:30 already. If not mistaken, we will have a 10-minute break, isn't it?
Yeah, that's correct, sir.
All right. So after the break, we will just continue with the function question and the others. So we'll have a break, like 10 minutes. Then I will see all of you again and 10 minutes later. Is it okay?
All right. Thank you so much, sir, for those great insights. I hope everyone is feeling inspired and ready to take on your exam preparation with fresh strategies and confidence. We'll be taking a short 10-minute break now. Feel free to stretch, grab a drink, or take a moment to breathe. We'll be right back at 10:40 a.m. to continue the workshop, so make sure to return on time. Just a quick reminder, everyone, if you have any questions or thoughts, feel free to drop them in the chat or on Slido, and we'll make sure to answer as many as we can during the Q&A session.
Why choose AUG? With more than 29 years of experience in the industry, we've been guiding students like you to their dreams. Our extensive network includes 26 offices across Asia Pacific, ensuring we're always close by. Offices are located in 5 major cities in Australia. We've proudly placed over 68,000 students across the globe. We represent more than 900 educational institutions in Australia, UK, USA, Canada, Singapore, and many more. Good people, great service, best outcome.
Are you worried about your education? You don't know where to start? Well, worry not. AUG's largest education fair is here. Meet face-to-face with representatives from leading universities. Discover scholarships and financial aids that can help your dream become a reality. Explore exciting programs, internship, and global study options. And the best part is, it is all free. So register now and be the first 50 students to win the free movie tickets.
Why choose AUG? With more than 29 years of experience in the industry, we've been guiding students like you to their dreams. Our extensive network includes 26 offices across the Pacific, ensuring we're always close by. Offices are located in 5 major cities in Australia. We've proudly placed over 68,000 students across the globe. We represent more than 900 educational institutions in Australia, UK, USA, Canada, Singapore, and many more. Good people, great service, best outcome.
Are you worried about your education? You don't know where to start? Well, worry not. AUG's largest education fair is here. Meet face-to-face with representatives from leading universities. Discover scholarships and financial aids that can help your dream become a reality. Explore exciting programs, internship, and global study options. And the best part is, it is all free. So register now and be the first 50 students to win the free movie tickets. See you there.
書くと見える、書くと広がる、書くと信じられる。頭で考えるだけではつかめない。書くことによってのみ生まれる想像への糸口。ゼブラは筆記具の力を信じている。どんな世の中になろうと人間には想像力を引き出す道具が必要だから。今こそ挑戦の輪を広げる。ただ手を取り合うのではなく、尊重し合い、ぶつかり合い、互いの挑戦を重ねていく。企業を超え、国を超え、それぞれが持つ技術や知恵を組み合わせる。筆記具の進化はそんな挑戦の輪でしか成し得ない。さあ、世界中の想像力が次々に花開く。その先には何が待っているだろう。ゼブラが描く未来にご期待ください。
Alright, everyone, welcome back. I hope you had a nice break and are feeling refreshed. Now let's continue with our workshop. Please join me in welcoming back Sir Matthew.
All right. Thank you so much. Okay, so let's continue. I hope all of you can see my screen. Oh, I need to reshare my screen internet. Wait. Okay, so function. Okay, this function question is a bit tricky because first thing is they doesn't give you fx, they give you f inverse. So what you need to do is you need to, okay, first thing you need to understand, if going this direction mean f inverse, so it's going opposite direction, it will be fx, isn't it? So I can straight away say fx is 7x minus m. Okay, so the other question give me this one. That's mean f4 will equals to 8m plus 1. Since this one is my fx, so what I can do now is I just sub the 4 into x. So I sub the 4 here. So 7, 4 minus m equals to 8m plus 1. So 28. This one m move here 9m. This one 1 move here minus 1 equals to 9m. So 27 equals to 9m. M equals to 3. Yeah, if you understand, it's not that hard. Then they want about inverse functions. So I will sub back into my fx equation. So my fx is equals to 7x minus 3. We just need to make the fx be a y so that it's easier for us to do. Okay, so what we do here is, okay, you can leave it fx, it doesn't matter. Okay, what you can do is the x you change to the y, fx you you change to the x. So x equals to 7y minus 3. Make y as a subset. Okay, so which is x plus 3 over 7 is my y. So therefore, my inverse function is x plus 3 over 7. Very easy 4-mark question. Okay, then we will move on to the b. It's given that the function g that map b to the map set b to the set c by giving this equation. Write down map a to c through the set b in terms of x. And now you imagine they have one more set here, which is a set c. Through the function of g. So they want to map like this. So what is the composite function you have? So you have f inverse first, then only g, right? That means you sub the f inverse into g. So this one we call g f inverse x. And the gx is given. F inverse x definitely I have here also. I write the gx above here, so easier to see. So my gx is x plus 6. X plus 6 over 5. So if I want to find gf inverse, that's when I sub f inverse into my gx. My gx is x plus 6 over 5. This one will be my f inverse, isn't it? So therefore f inverse is x plus 3 over 7 plus 6 over 5. Make them the same denominator, so I times 7, I times 7. So this one should be x plus 3 plus 42 over 7 over 5. So 5 is just beside the 7. So this is x plus 45 over 35. This is my gf inverse x. Okay. Okay, actually I did too much shortcut. I worry some students do not understand. Because if you have a over b divided by c, the shortcut is a over bc. So this is the reason why just now I moved the 5 beside the 7, so become 35. Yeah, this is, yeah, you can do the shortcut by yourself, divided by c. So this one is c over 1, right? So become multiply 1 over c. So it's a over bc. Okay, so yeah, so therefore b multiply c. Okay, these are some basic algebra. I assume you know how to do. Yeah, then we're done. Okay, here have some common mistake. A lot of students, they see f inverse g, then they thought this is f inverse gx. Not really, because your first function is always at the back, then this one is your second function. Yeah, it's a bit counterintuitive, but then yeah, this is how you get the composite function. Okay, cool. Number 6. Okay, they want us to derive sine 2x. Whenever you want to derive any double angle, you just use the a plus b formula. So I hope you still remember. I don't need to remember, actually it's given. You know sine a plus b, right? So this one is what? Sine a cos b plus cos a sine b. So therefore, sine 2x is 1x plus 1x, right? So you get 2x. So therefore, is sine x cos x plus cos x sine x. Cos x sine x is same meaning with sine x cos x, right? Because they are multiplication. So therefore, I got double of sine x cos x. Done. They just asked me to derive this formula. So this is how we derive. It's quite simple if you get the idea. Then B, they asked us to solve it. Yeah, sine 2 sine x cos x equals to cos x. Okay, remember, when we are doing trigonometry, we don't cancel the cos x like this. Because some students might say, sir, why can't I just divide cos x here and divide cos x here? cancel. Then we will get 10 equals to 0. 1 cos x is 0, yes. You will get 90 degree and 270 degree, right? But if cos x equals 0, can you divide 0 at the bottom? No, right? You cannot divide 0. Because if you divide 0, you will get math error. This is reason number 1. Reason number 2, because cos x equals to 0, it have value. Yeah, I assume that do something like, some y, or normally 2xy equals to y, we also won't divide like that. Yeah, unless you have something like 2. Then you can divide 2, and then you say x equals to 1. Yes, we can do like that because 2 itself is a constant. But normally it's a variable, we don't do divide like that. So what we do is we move to the other side, become minus. Then we factorize cos x. Because cos x equals 0 have the value. So we need a reason why we don't divide. Then we'll solve something like this. Cos x equals to 0 and sin x equals to 1 over 2. Cos x equals to 0 is 90 degrees, which is pi over 2. You should know pi is equal to 180. These are basic knowledge only. So this one is 30 degrees, which is pi over 6. But why I never find a second angle? Because they want a range from 0 to pi, which is first 2 quadrants only. So I don't need to find any value. Hey, this one got one more. 150 degrees, which is 5 pi over 6. Of course, you can use a calculator. You can use a calculator. But change the calculator into a radian first. You get pi over 6. So second quadrant is pi minus answer. This is how I get a 5 pi over 6. Okay, so you can do shift cos 0. The calculator will tell you pi over 2. Okay, because these are all spatial angle, so I just memorize it. But then yeah, you can use calculator. No worry. But change calculator to radian. If not, they will tell you degree. But then the range given is radian, right? So yeah, you must change to radian before you type in the calculator. Okay? Anything you want to ask me? No? Then we'll continue to the third. Okay, so we have they ask us to find a tangent square for this one. ACB. So ACB is this angle. This angle. But the problem is what? Tangent is OA. Opposite over adjacent. I do not know my adjacent. So this is the reason why I need to do the Pythagoras to find the BC. So BC will be square root of the 2 square minus, hypotenuse minus another one. So it's basically m square minus 2 because 2 square is 2, right? Okay, now I have the BC already, which is m square minus 2. Okay, now I can do the tangent ACB first. I know there's a square, we do it later. Opposite over adjacent. Okay, then they want to get tangent square. That means I square here, I square here. Then I should get 2 over m square minus 2. Okay, hence, I find the value of ACB, the angle ACB, if m is 2. So therefore, tangent ACB, a square put here first, 2 over 4 minus 2, which is 2 over 2, which is 1. Square move that, becomes square root, plus minus, tangent ACB. Okay, then we want to find ACB. We will inverse tangent of square root 1. Then you might ask, sir, there's a plus minus one. Why don't we do a minus? Okay, you need to know add sugar to coffee. Tangent, get positive in the first quadrant and third quadrant. Definitely cannot be third quadrant. The third quadrant more than 180. We are doing triangle. triangle don't weigh more than 180. Then you might say, sir, negative means second quadrant, what? More than 90. Now you have to ask yourself, can theta more than 90 degrees or not? If your answer is yes, then you don't know triangle so well. Because here is already have a 90 degree. If theta more than 90, then triangle more than 180. This is mathematical reasoning. So therefore, we only take positive one, which is, yeah, this one is plus minus 1 lah, but we only take the positive 1. Okay, which is 45 degrees. Okay, so because another one is 135, but in these cases, theta is not possible to be 135, so this is the reason why I doesn't include that. Okay, these are all small details, but then I wish you understand, so that in a real exam you can do better lah. Okay, is it all okay? I'm going to move on to number 7. Okay, it's a progression. Diagram 6 show a few gray color isosceles triangle pattern drawn on the nets of a rectangle roll of paper. So it's given a length of AB is P, BC is P plus K, CD is P plus 2K, and subsequently. So express the area of the second isosceles triangle in terms of P and K. Okay. So the first one, this is the height of the triangle is P. The height of the triangle becomes P plus K. The height of the triangle becomes P plus 2K. So you ask me, sir, how about the next one? Height P plus 3K. Because obviously they give 1 plus K, right? It's quite easy. And the base of the triangle is 20. Constant, because all of these have the same base of 20. Okay? So they want the isosceles for second triangle. Area of triangle, half die, base times height. Half die, base is 20. Height is P plus K. So it's 10 P plus K. Done. This is a second triangle, A2. 1 mark only. Okay, given an area of the 15th and the 30th, isosceles is 700 and 1300. Find the value of P and K. Okay, now you must be very careful when you do it, because a lot of students will use this one as a progression. You can, but it's less effective. Because why? This P plus K, P plus 2K represent the height. But right now, we want to find area. So therefore, I prefer to have a progression designed for area. So it's easier for me to do that way. So therefore, first area is 1/2 base times height. Second area, we already done, but I show you also. Times height. Third area is 1/2 base times height. So you can see only height is changing, right? So from here, I have a progression for area. This is 10P. This is 10P plus. they can only go to the left hand side. The area cannot go to the right hand side. This is default by this calculator. So therefore, if I want to use this calculator to solve this question, I cannot insert 0.9. I need to insert 0.1. Because 0.9 is from this line go to the right hand side. You see they go bigger one. This area is 0.9. But then this calculator default inverse normal must be go to the left hand side. So therefore, if I go to the 7, do you see inverse normal number 3? The area must be 0.1. Then the calculator will tell me this answer, which is the answer we got just now, negative 1.281 or 282. Like just now I say can subtract 2 or subtract 4, right? Okay. And some students might curious, sir, why you never change the standard deviation and mean? Okay, if I put the standard deviation at 1 and mean at 0, this is the standard normal. That means I'm finding the z value. If today I want to find the x value, which is a h here, I want to find a h straight away from the calculator, then I will change my mean and standard deviation. So, my mean is, my standard deviation is 15, right? My mean is 320, right? So if I change already, then the calculator will tell me my x answer. Enter. This is the answer just now, isn't it? So the calculator will straight away tell me the x answer. But remember, if you want to find the z, because you need the working, so you need the z value. So this is the reason why I recommend you use 1 and 0 as a standard to get back this value. Okay, these are just calculator tips. I hope it's helpful to you. Then we have about few more minutes, so we will discuss one more question. Choose. You want index number or solution or triangle? If it's no one what, then I will just choose the one. Okay, student choose index number. Okay, then we do index number. Okay, for index number, okay, so they want to make some kueh, pokok ubi. I guess it's some ubi kueh. I do not know what kueh it is, but yeah, it's some kueh. So these are the ingredients. They use coconut milk, tapioca, which is the ubi kayu, and then you use brown sugar, and then they use tepung, the rice flour. So okay, so they give us year 2024, 2021, and this one is the index number 2024 based on 21, and then this one is the volume. Is the volume they use. Basically, this one is what we call weightage, or in a Malay they call perberat. Okay, so we have almost everything we want here. Then they ask us to find x and y. This 3 mark normally is the bonus mark. So, okay, x is here. So yeah, this is the index number. This is the index number 2024 based on 21, right? So therefore, if you have the index number 24 based on 21, the formula is very easy. We can put the price for 24 over price for 21 times 100. This is the formula given at the formula list, so it's no surprise. So in these cases, index number is 108. 24 price is x. 21 price is 20 ringgit. So we multiply 100, then we easily get the x. So the x will be 1.08. Oh, sorry. And what happens? 1.08 multiply 20. So it's RM 21.60. Money always live in 2 decimal. This is the SPM standard. Okay, then for the second one, it's the same thing. Index number is 150. Price for 2024 is 4 ringgit 80 cents. Price for 2021 is Y. Then we multiply 100. We will solve this one. Okay, so Y should be 4.80 divided by 1.5. So I do have shortcut, but I assume you know the basic algebra, so I doesn't show you how to move around. So the money will be 3 ringgit 20 cents. Okay, so yeah, I'm done the part A. It's a 3 mark. This 3 mark is extremely easy. Just apply the number into a formula. Nothing very special. Okay, then we go to the part B. The composite index for 2.1 based on 2.4 based on 2.1 is 125.3. Find the value of M. Okay. So composite index formula, I believe, is given also. Sum of index over weightage over sum of weightage. So I will do this one. You should know is W. So I do sum of W first. Sum of W is 10 plus M. Okay, you can just plus yourself. This one plus this one plus this one plus this one. Okay, sum of W. Then this is I. I multiply W is IW. So I'm going to multiply them here. 130.5 multiply 7. So we got 913.5. This one 120 M. This one 216. This one 150. So then I want to do sum of IW. Basically mean all the number here we plus together, isn't it? So yeah, I'm going to plus here. The number is a bit big, but yeah. The plus 216 plus 510. Okay, the M, the one which M I never plus, 1279.5 plus 120 M. Okay, now I have this thing and this one, which is sum of IW and sum of W. Then I sub into the formula. So if I sub into the formula, the composite index is given. Composite index is 125.3. Okay. 125.3 equals to sum of IW 1279.5 plus 120 M over 10 plus M. So as long as I solve this equation, I should be able to easily get the equation, the M I want, plus 125.3 M equals to 1279.5 plus 120 M. This M and M settle, I got 5.3 M. This number I settle minus 1253. I get 26.5. And my M divided by 5.3. My M is 5. Okay, done. Okay, this composite index is simple. Okay, just like that, just sub in. Nothing special. Okay, then we go to the C. Okay, the cost of making a dozen a pack of the kueh pokok ubi increased 35% from the year 2024 to the year 2026. Okay, increased 35%, that's mean index number is 135. Always base value is 100 in the index number, so increase is 100 plus 35. So this one is index number for 26 based on 24. Okay. So the selling price of a dozen pack of the kueh pokok ubi is 72 ringgit with a profit of 72 ringgit. This one is with the profit of 24 in the year of 2026. Calculate the cost of making wow, okay. Okay, so I want to know the cost first because they make the profit of 24 ringgit, right? So cost will minus 24 okay? Cost will be costing in this year will be RM48. This one is costing. Okay, so they want to know the cost in 2021. So right now, it's very important you take this value rather than any ingredient value here, rather than any index number here, because they want the overall, they want the index number represent the kueh, not represented by any ingredient. So therefore, I will take this one, which is the index number for 24/21 is 125.3. Okay. But over here, composite index also an index number. You have 3 different years, right? Smallest one is 2021, and then you have 2024 and 2026. So, if you want to find the index number, this one to this one is to this one. I mean, this is the index number of 26 based on 21, right? is basically equals to both of these index number multiply divide by 100. This one is the index number of 24 based on 21. This is the index number of 26 based on 24. Multiply, divide by 100. Then you get the whatever above, 26. This is the so-called umbrella method. Okay, so yeah, so we just insert all the information we have here. So 2421 is 125.3. 2624 is 135 over 100. Then I should be able to get index number for 2621. Then I just type the calculator lah. So therefore, my index number for 2621 is 169.15 or 16. Okay, this one means what? Means price for 2026 over price for 2021 times 100, I will get 169.16. And then they tell us we know the cost in 2026 is 48 ringgit. And ask us to find the cost in 2021. Yeah, so we just substitute 48 on the top and solve this equation. So 48 of price of 21 equals to 1.6916. So price for 21 equals to 48 divided by 1.6. This value lah. So we can know the price now. 48 over 1.6916. So the costing at 2021 to make this square is about this price, 28 ringgit 38 cents. Yeah. So for index number, normally only the last part of it is a bit confusing. I would say part A and B is just a bonus mark, just a part C. Sometimes it will be a bit confusing. They give some revenue, they give some profit, costing and all that. You need to like solve a bit. But this question not that hard. I see a lot harder one. Yeah, sometimes the even harder one, they give you two different tables. And then they want you to join two tables together. Those are more complex of the index number lah. All right. I want to thank all the students who are able to stay until the end. Yeah, is there anything else you want to ask me before? Yeah, so I pass back to the host lah.
Yeah, okay, thank you, sir, for that. Now it's time for our Q&A session. So if you all have been submitting some questions during the presentation, so let's dive into this. Since our time is limited, maybe sir, you can just answer about 2 questions only, then the rest we'll get to them later.
Okay. And a function. Can you prove sum to infinity equation why R must be between -1 to 1? Okay, this one sum to infinity is quite take some time to prove, but I can just explain about this one why R must be 1 between 1 and -1. The reason why is something like this. Let's say I give you some simple one 2, 4, 8, 16 and so on. So your A is 2, your R is 2 also, right? So if I use sum to infinity formula, see is it possible A over 1 minus R? A is 2 over 1 minus 2. Then this one you will get -2. That means you sum all the number, you get -2. Do you think it's possible? I just sum 2 number already 6. Then I sum this number is like, it's already like 16, then 32 and so on. Impossible, I sum all the number, I get -2, right? So then you will get an invalid value lah. But I think sum to infinity, you can go back to the textbook. Textbook should have the proof for it lah. Can you explain against the 4A1? Oh. Yeah, I thought this kind of question you will ask me about on the spot. But yeah, sure, I can explain again for this one real quick. So dt, this one is t squared over 2, 1 minus t. So this one is 2gt. Because the question asked me to integrate, so I add the integration sign for both sides. And then integrate me, I can cancel. This is my question. Question asked me to find this one. So the only thing I need to solve is move the 2 to the other side, become 1 over 2. Then I do a plus C, then I done the entire question. It's very simple. Yeah, maybe I just see anything I want to answer. How to improve that a function? how to prove the function has the inverse again, and how to explain it. Okay, remember, for inverse function, there must be always one-to-one type of relation. One-to-one. Example, today, let's say I have a quadratic. Quadratic is many to one. How do I know? Because if I draw a line, horizontal line test, I intersect 2 points. It's many to one. Many to one can never have inverse. But the K-bar question, what the K-bar question will do is, they want to make a quadratic have inverse function. But quadratic is many to one, right? Cannot have inverse, right? But I can limit the domain. That means, let's say this one is 3, 5. I say, when my x is bigger than 3, that means I only take this part of the graph. That means I only take this part of the graph. I erase here. Do you see? If I add the domain, right now my quadratic become one-to-one function. Then inverse can exist. If not, I take the entire quadratic graph, inverse function can never exist. Okay, this is something you need to know. What is the requirement for best fit line? Best fit, the top part, the point you miss on the top and the bottom must be balanced. Top you miss 2, bottom miss 1, acceptable. Top 2, bottom 2, acceptable. But top you miss 3 points, bottom you miss 1 point, this is not the best fit. That means, this is a line, the top and bottom, the point you miss must be balanced. And the straight line must touch as many points as possible. Okay, this is the requirement for best fit. What is the best strategy for paper 1 and paper 2? For answering the exam question, the best strategy is you always answer the question you are confident first. How do you know the question you are confident? When you read one time the question, your mind is already have solution. Then you do those questions first. If those questions you read 1 time, 2 times, your mind still doesn't come out any solution, skip first, come back after you finish all the questions you're confident. Because answering the question is like playing game. You want to score those level, you can easily get most of the point. So yep, this is how you score it. So yep, any more questions? If no, then I think I pass back to the host.
Alright, thank you, sir. So now that your doubts have been cleared, it's your turn to answer questions from Sir Matthew. To make this session even more exciting, we're giving out Grab vouchers to participants who answer correctly. We have 2 Grab vouchers worth 10 ringgit each, so don't hesitate to join in. To participate, just raise your hand. When we call on you, unmute your microphone, introduce yourself, and the first person to answer each question correctly will win a voucher. With that, sir, you may begin asking questions to the students.
Ask how many questions? 2 questions, is it? Oh.
Yeah, just 2 only.
Oh, okay, yeah. Okay, yeah, so let's say today, if I have the 5 log 5 k, what is the answer?
Hi, I'm Singing. Answer is K.
Yeah, answer is K, correct. Okay, then, okay, I ask one more. Any question? Okay, okay, today let's say you have y equals to 3, x minus 5 squared, x plus 5 squared, minus 7. First, is it the maximum or minimum? And then what is the coordinate? Or what is the coordinate of the turning point? Which is the vertex? Any student?
Is minimum 5, negative 5, negative 7.
Yeah, good job. It's correct.
Alright. Congratulations to the winners. You can share your email address in the chat box or WhatsApp us at the number provided in the chat so we can send you your Grab voucher. So for those who didn't get it right this time, don't worry, there will be more Grab vouchers in the future sessions. So, wow, that was such an engaging and informative discussion. Thank you, Sir Matthew, for sharing your expertise with us today. I believe this informative session by Sir Matthew has helped all of you feel more confident and ready to approach your exam preparation in a focused and stress-free way. So, before you go, please turn on your cameras as we would like to take a group picture together.
It's a real you will be live in high school dot. Yeah, I will have the live at high school dot my tonight also. But then tonight I'm using the Mandarin to do a live. Yeah, it's a different platform. Yep.
Okay, so once again, thank you, Sir Matthew, for today's session, and thank you guys all for attending the session today. If you have any additional questions or support, feel free to reach out to us after the workshop, and don't forget to follow us on our socials. Before we wrap up, we would also like to take a moment to express our gratitude to those who made this event possible. A special thank you to our gold tier sponsors, AUG Student Services, BAC Education Group, and New Era Enterprises for their generous support. We also want to thank our collaborators, Student Action Club Inti and SMK Subang Utama Leos for their fundraising efforts. If you have not noticed yet, New Era Enterprises has provided all of you free art lines and Zebra's Shopee e-vouchers, so make sure to claim yours before they're gone. Just scroll to the sponsor section in our digital event booklet and scan the voucher QR code or copy the voucher code for your next purchase. So before you go, please take a moment to fill out our feedback form. Your input is invaluable to help us improve our future workshops for SPM students like you. Make sure to join us next Saturday, 7 December at 9 a.m. for another informative workshop focused on the biology subject. And keep up the great work with your exam prep. All right, thank you, everyone.
Bye bye.